We look at example 3 now. Now in example 3, there is a A and there's a B such that your probability of Z less than A is equals to B. Now in particular, they tell you that B is a number that's less than half, and they want you to find in terms of B the probabilities in 1, 2, and 3. Now, do you remember what Z is? Z is the standard normal distribution. Okay, that means I can write this down. It has mean 0 and variance 1. Alright? Now, in this kind of question, it's usually good to draw a rough sketch. Now, the reason why we advise students to draw a rough sketch is because we can quite often make use of properties that we talked about earlier, for example, symmetry, to help us figure out what the probabilities are. Okay? So let's take a look at this rough sketch. Now, this is of course a bell. Okay, the normal distribution is a bell. Okay, in particular, it's centered, or rather it's symmetric about the line Z equals to 0. Okay, and then if you look at what you have been given, probability Z less than A equals to B, your B is actually the area under the curve. Okay, or your probability. And your A is something on the line, on the axis. A is something on the axis. So if I were to transfer all this information onto my rough sketch here, okay, then I know that my A must be a negative number. Now, that's because if A is not negative, let's say A is positive number, so A will be somewhere here, then probability Z less than A is actually this shaded region. But quite clearly, you can see that this shaded region must be more than half. Okay, because the shaded region has included not just this half of the curve, but this half as well. So because this half of the curve, okay, the area under the graph is half. So it must mean that the area must be bigger than half. So that's why A cannot be a positive number. It has got to be a number on the left of 0. That is a negative number. Okay? Okay, let's look at part 1. Now if you look at part 1, you're asked to find probability Z less than, bigger than, A. So this is a nicer looking diagram than the one I have drawn, but essentially it's the same one. Now they tell you that I want to find probability Z bigger than A. Alright, now what you have been given is probability Z less than A equals to B. And then actually all I need to do now is to say, oh, Z bigger than A is actually the complement of Z less than A. So I can use the complementary rule to write this out. 1 minus probability Z less than equals to A, okay, must be 1 minus B. So this is your answer to probability Z bigger than A. Now you can see this from your diagram. The shaded region here, this is your probability Z less than A. And the non-shaded region is actually your probability Z bigger than or equals to A. Okay, so if I want to find this, or rather without the equal sign, then all I need to do is to take 1, which is all the probability of all things occurring, all possibilities. That's 1 minus probability Z less than or less than A. Okay, and then you have this. We look at B. Now B wants you to find what? B wants you to find probability Z less or bigger than minus A. Okay, so how should I do this? The first thing I do is I will try to locate where my minus A is. Now because of symmetry about the Z equals to 0 line, minus A is symmetric and is here. Okay, remember A is a negative number, so minus A must be positive. So Z bigger than or equals to minus A is actually this shaded region. Okay, is this area here. Okay, so if you look carefully, this area, it must be the same as this area because of the symmetry. Okay, So that means probability z bigger than minus a is the same as probability z less than a. And that's how you get b. Okay? We look at the last one. Now for part 3, you want to find probability z less than minus a. So again, I will do this. I will look for minus a first, okay, which is here. Then I'm looking for z less than minus a. In other words, I'm looking for this part, the part that is highlighted in yellow. You want to find the area under the curve, okay, for the part that's highlighted in yellow. So I have already got the answer from part 2, okay, which I can use it in the complement, because the area that is highlighted in yellow is actually the complement of the area that's highlighted in green. So your final answer is just 1 minus probability of z bigger than or equal to minus a, and this from your earlier part is just b. So that's why your answer is 1 minus b. In the last part of the question, okay, the question asks you whether the answers that you have here will be different if b is bigger than or equals to 0.5. Now the answer is that they will be different. Can you try this on your own? Now we look at example 4 now. Now example 4 is very similar to example 3. You have a and b, okay, two constants such that your probability mod z less than a is equals to b. And conditions given are your a positive, b between 0 and 1. And you want to express your probability z less than a in terms of b. So if you remember, earlier on we said that z is a standard normal, and if you were to draw a rough sketch, you will know that the rough sketch has got a line of symmetry about z equals to 0. Okay, it's bell-shaped. Then let's put this information into our diagram. Now if you don't want to see mod z, then let's apply what you learned last year in your first chapter, the very first chapter on inequalities. This mod z can be changed to z bounded by a and minus a. So instead of looking at this, now you have this condition that allows you to mark down your minus a and your a and shade the region that is b. Okay? Now, this graph is symmetric about z equals to 0. Now, this means that this region here, this area on the graph, is the same as this area on the graph. Then isn't b, the area that is shaded in blue, plus 2 times the area that is shaded in green, that means just this part, okay, which is probability z bigger than or equals to a, can you see here, a, equals to 1. In other words, the total area under the graph, which is 1, isn't it just the area that is shaded in B and 2 times of this area? Because these two areas are symmetric. Now if that's the case, then you can now write down probability z bigger than or equals to a to b. You bring the b over, you have 1 minus b divided by 2. There you go. So once you have found this, once you have found probability z bigger than or equals to a, I can now find probability z less than a, because this is just the complement. So probability z less than a is 1 minus probability z bigger than or equals to a, and this number here, I have just found this here, alright, and then I can replace it, and then I can add the two together to get this. 1 plus b divided by 2. Done. So you can see, drawing a nice diagram can really help you to get your answers very quickly.